Hi there. Here's my solution involving the two-sample t-test for means review problem. So we have two treatment groups here. We have 20 randomly selected men from a large hospital, all of whom are being treated for high cholesterol. So group A, there are 10 men who are advised of exercise and diet, and these 10 receive a placebo. Then there's a group of 10 men that are similarly advised on their exercise and diet, but instead of receiving a placebo, they receive the actual cholesterol medication. So we're interested in if there's a difference in the mean reduction between the control group and the treatment group. So it's always good to first define your parameters, mu A, and notice it's convenient here that actually on the AP question they're labeled as group A and group B. When that happens, I would encourage you to use those same labels on your parameters. So mu A, that is the population mean reduction in cholesterol, but that was for the placebo group, that's our control group. And then mu B, that's the population mean reduction in cholesterol for the drug group, that's the treatment group. So always state your null and alternative hypotheses using your population parameters. If the treatment has no effect, the two means would be equal, or the difference between the two population means would be 0. So according to the question, we are interested in, at the 1% level, is the cholesterol drug effective in producing a reduction in mean cholesterol level beyond that produced by diet and exercise? So we're interested in if in the treatment group, if its result is bigger than the control group, or similarly, if the control group's mean reduction is less than the treatment group's mean reduction. So if you do mu A and mu B in that order, it has to be a less than alternative, and the difference would be less than 0. If you want to switch the orders, that is fine. Then you would use a greater than alternative. Either way will be okay. So beyond, though, that is what indicated to me that I was interested in a value from the treatment group that was higher than from the control group. Notice also we are given the level of alpha, or we're given the level of significance to which we want to compare. That's the 1% level. So always check your conditions. There are 3 of them. The randomness condition, I would not use the word simple random sample here because there's no indication of that. But in the wording, we actually, if you go up and take a look at it, it says 20 middle-aged, here it is, 20 middle-aged adults, and these were randomly selected from the population. Then 10 of the 20 were, there it is again, randomly assigned to group A, and so forth. So when you write about the randomness condition, I wouldn't use the word SRS, but you can mention that 20 randomly selected males, and they were randomly assigned to the 2 groups. That's important. In terms of independence, the question actually says, we have selected 20, or 10 times 20 would be 200. So I want to believe that the, quote, population of such male patients at a large hospital, that's actually how it came from the wording in the question. I would hope that that population is more than 200 in terms of my independence. And then for normality, understand my sample size is combined 20. That's less than 30, so that's not enough to invoke the central limit theorem. But if we look at the sample data, you can see that there are no outliers. You can also see that the sample data exhibit little skewness, so it's okay to use the 2-sample t procedures. I actually have the data ready to go in this calculator, so I'm going to take a second and actually plot it for you. So I'm going to simultaneously plot a histogram. So I'm going to change this to list 1. So that's where my control group data happens to be. My placebo group data is in list 1. And then I'm going to turn on the second plot. It's already turned on. It's a box and whisker plot. Also, I'm going to change that to list 1. That is my control or my placebo group data. So I'm going to make sure none of the other plots are on. They aren't. Looks like we're good to go. Check my y equals menu. There's nothing in the y equals menu that might get plotted. We're good to go. So if I press zoom 9, that will give me a quick plot. I like to, as you've heard me say a number of times, I like to go in and clean up the window a little bit. So I can take my minimum down to 0. Maybe I'll make my max 30. I like to cut my scale a little bit. Maybe we'll make it 3. Just cleaning up the window a little bit so we can get a better picture of what the data look like. So again, mostly I'm interested in no outliers and not a lot of serious skewness. So when I look at that, I don't see a lot of outliers. Actually, there are no outliers, and there might be some slight skewness to the right, not enough that would be of concern. And we should then take a look at our treatment group data. You should look at both sets of sample data. So I need to change these to list 2. That's where my treatment group or my cholesterol drug medication treatment group is located. Need to change both of these to list 2. Takes just a second. Again, I'm going to zoom 9 the data. There we go. Oops, forgive me, hit the wrong button. Try that again. Zoom 9 the data. There we go. Well, frankly, I don't even need to really go in and clean up my window very much. The histogram, frankly, looks pretty symmetric. The box and whisker plot doesn't demonstrate any outliers, so I think I'm good to go in terms of my normality condition, so we can go ahead and conduct the test. Something to think about then, you need to name the test. So this is a 2-sample t-test. So we have a sample of mean reductions from the control or the placebo group and a sample of mean reductions from the cholesterol drug group or the treatment group. So you need to indicate a t-score, a p-value, and also the degrees of freedom. Both the degrees of freedom and the t-score are important. You would need both of those written down. If there was something wrong with your p-value, both of those would be required in order to reproduce that p-value. So let's just go in and run the test. Something convenient here, if we go to the stat button and go over to tests, again, it's the 2-sample t-test that we want. There it is. So I've already entered all of the data into my calculator, so I'm going to run the test based on using lists 1 and list 2. I've specified the correct alternative hypothesis, the less than hypothesis already. Notice though that in the original question, underneath the tables, the sample means and the sample standard deviations were given to you. So of course, to check the condition for normality, you really need to plot the data. However, you should understand that if you are only given the summary data, so the mean reductions from the 2 groups and the standard deviations of those 2 groups, that would be good enough to actually run the test. So you would select instead the stats option. And under the stats option, then you could enter your mean, your standard deviation, and your sample size from the control group. And then you could do the same for the treatment group. I've already got the data in there, so I'm just going to use my data in list 1 and list 2. We'll run the test. There we go, never pool. So there's the t-score of negative 1.62, we'll call it, and the p-value of 0.062. So the degrees of freedom also, let me go back to the calculator real quick. If you scroll down, you'll see the degrees of freedom. Or forgive me, maybe it was up. I apologize. I've written it down. Oh, there it is. I'm sorry. So right below the p-value, there's the degrees of freedom at about 17.3. So it's important to note all of those on your actual work. So there's a t-score, negative 1.62. The p-value is 0.062, and the degrees of freedom are 17.3. And then we write about this test just like we would write about any statistical test. So include the p-value. With a p-value of 0.062, you need to compare that to your significance level or your level of alpha. That was given to in the problem as 0.01. So our p-value is greater than that. That means that we are unable to reject the null hypothesis at that 1% level of significance, that level of alpha that was specified. So then always describe what you now have learned about the alternative hypothesis. So in this case, we did not reject the null hypothesis, so we do not have evidence that the population mean reduction, so again, you need to talk in context, write in context. We don't have evidence that the population mean reduction in the drug group is greater than that of the placebo group. We don't have evidence of that specific alternative hypothesis, so make sure you specify the direction of the alternative hypothesis and make sure you discuss it in context. There is a complete 2-sample t-test regarding 2 means, treatment group, control group. Hope this has been helpful.